Okay, so yesterday we have seen the implementation of insert at end, insert at beginning, insert after, display, and then remove last function for the circular linked list. So today we shall be seeing remove given, then remove before. Okay, with that two functions, we'll be completing the implementation of circular linked list. So let's begin with remove given. So this is the remove given function for the single linked list, and we need to convert this function to circular linked list. So let's see if the list is empty. So if h is null, then the list is empty. Nothing we are going to do. In the else part, what we need to do, we need to search for the given node. We need to search for the given node, and basically we need to remove that given node. Okay. So what we did in the single linked list in SLL, temp equals to h, then pre equals to temp, and then while temp not equals to null, and at the same time temp of data not equals to k. Okay. Then pre equals to temp equals to temp of next, and then if temp equals to null, it simply means that the given node does not exist, and then return h. And if h equals temp means if it is the first node, then modify the header or the head pointer. So h equals to h of next, else pre of next equals to temp of next and pre temp. Okay. So this was the logic for the SLL. Now we need to convert the same this logic for the CLL. Okay. So what we'll be doing, we need to just play with few of the conditions that while temp not equals to null. Now we know that in CLL we do not have null pointer. Instead, the last node always points to the first node. The last node points back to the first node. Okay. So here you need to write temp not equals to h. But if you write temp not equals to h, then for the very first check, the condition would fail. Why? Because we are initializing temp with h. Yes. So since we are initializing temp with h, so if we write here temp not equals to h, so the condition would fail for the very first check, and it will come out of a loop. So we'll be doing the same thing what we did in the earlier function. Uh, we can say that temp of next not equals to h. Okay, and in that case, you will be missing out the last node. What I mean to say that we will not be comparing the data of the last node with the given key element. So that we need to check additionally after this. So what I can say, instead of null, I would be writing h, and this should be temp of next, for example. And then after this, the last node needs to be checked. Okay, because in the while loop, we are not checking the content of the last node with the key value. Okay, because this condition temp of next not equals to h, this condition would be false for the last node because last node next pointer equals to h. It's a circular link. Okay, so last node next pointer equals to h since it is a circular link list. So for the last node, this condition would be false and will come out of a while loop. So we are not comparing the data of the last node with the key value. So the given node can be a last node. So here we need to make that additional check that if temp of data equals to, or I can simply say not equals to key. If this is the case, then I would be simply saying temp equals to temp of next. Okay. And not only this, before making temp equals to temp of next, we need to get the value of temp into prev. Okay, so prev equals to temp. So simply whatever we have into the while loop that we are putting over here, and then after this, if my h equals my temp equals h, uh, my temp equals h, and at the same time, because temp equals h, it also means that there are two possibilities. Try to understand. When temp equals h, so it does mean that you have traversed or you have searched the entire circular limb list, and you have searched the entire circular limb list. But at the same time, you need to confirm that the data of this temp is not key. Else, it is a possibility that temp is pointing to h, and it is a first node, and that first node data equals to key. So in that case, this would fail. Okay. So here I need to say temp of data is not k. Okay. So temp equals to h, and at the same time temp of data not k. Then I say that the given node does not exist, and we simply return h. And if that is not the case, so there is a possibility that the given node is the first node. So if h equals to temp, h equals to h of next. Else, prev of next equals to temp of next. Yes, fine. Then free temp and given node removed. Yes. Okay. I hope that this should work. So let's save this. Let me compile it. This is remove given. Where we are calling the remove given. Let's check that also. So we are calling it in the fifth case, remove given. Enter key. Okay, that's fine. Okay, so the code got compiled with some errors. Let me stop something. Not equals to h. Make sure. Okay, got compiled. This is executable. Let's execute it. And let's insert few nodes. So say 10 and then 20 and then say one more node 30. Display. So 10, 20, 30. This is our circular limb list. And then the size of the list is 48 bytes. Okay. Now let us try to remove the given node. So the option is fifth. So I go for the fifth option, and let's give a node which does not exist. Let's start with that condition. So let the key value be 40. Okay, so we are getting a message that the given node does not exist. So that condition is done. Let us check the list. Yes, the list is intact. Now again, remove given. And now let us remove the intermediate node, that is 20. Given node removed. Let's check. Okay, yes, 20 has been removed. Now let's remove the last node. Fifth option. The given key value is 30. It says given node removed. Let's check. Yes, it has been removed. Let's remove the only remaining node, that is 10, which is the first node and which is also the last node. Says removed. Let's see the content. Oh, circular English content is this. We know. So the problem is when we try to remove the only node remaining in the list. So what's happening? Yes, yes. If what happens in case of single English when there is only one node in the list? So we come to this condition. If the given node is the only node, okay. So we come to this condition, and here we say h equals to h of next. Now please try to visualize. In case of single English, if there is only one node, so the next pointer of that node is pointing to null. I repeat, the next pointer of that node is pointing to null. Okay. So when we write h equals to h of next, h becomes null. In case of SLL, h becomes null. So our list is empty. But in case of CLL, what's happening that when there is only one node and you are trying to remove that node, and then the given node is the only node which exists in the list, so this H would be equals to 10. Yes, condition is true. Now, when you go inside this if, what we are writing, H equals to H of next. Now, H of next is pointing to itself. This is CLL, circular. So H of next is pointing to itself. So when you write H equals to H of next, so it is again getting the same value. It is again getting the same value. So that single node uh, is not getting removed. Okay. So what we need to do here, we need to have one additional check. See, this check is applicable if the given node is the first node, and this check is applicable if the given node is the only node. So this condition is getting true for both the possibilities. Okay, and this is absolutely perfect if the given node is a first node and there are multiple nodes and there are multiple nodes. Okay, and this and there are multiple nodes. So I can write here h equals to temp, and at the same time, this is not the only node. So h of next not equals to h. So when h of next not equals to h, it means that there are a few more nodes. And in the else part, I would be saying in the else part, I need to give one more condition. If h of next equals h, it means that this is the only node. So in this case, I would be writing h equals null. We are making the list as empty list. Else, sleeve of next equals to temp of next. Okay. So inside this else, basically you have one more if else. Fine. Now this should work. Let me compile. It will say code already running. Let me restart. Let me compile now. It got compiled. This is the executable. Insert few nodes. I insert two nodes only, 10 and 20. Display the list, 10, 20. Okay. Now remove given. And first I remove 20. Node removed. Let's display only 10. Then I remove 10. Node removed. Let's display yes. So now the linked list is empty. Okay. So now it is getting done properly. And let's check it once again for all the conditions. 10, 20, and one more insertion, say 30. I display the list 10, 20, 30, then remove given. Let me go with the number which does not exist. So given node does not exist. Then remove given. Let me remove the last node 30. Yes, it got removed. Then let me remove the first node now 10. Oh, again, so this is a problem when we are trying to remove the first node and there are multiple nodes. Yes, yes. Can anyone tell me where we are stucking? What is the problem here? Come on. When we are trying to remove the first node, when there are multiple nodes. So basically this condition, sorry, sorry, this condition. If h equals tmp and at the same time h of next node equals to h. So the given node which we need to remove is the first node and there are multiple nodes. I repeat, the given node is the first node which we need to remove and there are multiple nodes. So this is the condition for which our code is failing. Our code is not doing the desired thing, and instead we are, destroying our list. So what's the problem over here? Please tell me. Come on, fast. The code is in front of you. The code is in front of us. I am telling you where is the issue. The issue is into this part, which is highlighted. If h equals temp and at the same time h of next not equals to h. Okay. And what does it mean? It simply means that the given node which is pointed by TMP is the first node because h equals TMP. Okay. So the given node which we need to remove is the first node and at the same time ampersand h of next not equals to h. It means that there are more than one nodes in a given circular linked list. There are more than one node because h of next is not equals to h. Okay, so there are more than one node, multiple nodes. So this is the condition where our code is failing, you can say, or where the code is breaking and your list is getting destroyed. So what's the solution? Into this, we are writing h equals to h of next. What do we need to write? Come on, fast. Chalo, get me some solution. First, let me know what's the problem. Why the code is breaking and why our list is getting destroyed when we are getting into this condition. When the node which we want to remove is the first node and you have multiple nodes in the list. There are more than one node and you want to remove the first node. So there the code breaks. Okay. If you want, then I can execute it again and can show you. You are having multiple nodes. So I am inserting 10, 20, one more insertion, so 30. I got multiple nodes in my list, circular link list, 10, 20, 30. Okay. I go for remove given, the fifth option. And here I put up the key value as 10. So I am trying to remove the first node. The first node is having a key value of 10. Okay. Now, the first node is having a key value of 10. And then what is important that your list is having three nodes, 10, 20, and 30. Okay. So first node you want to remove. So that's why we are giving a key value of 10. We want to remove the first node. And this list is having three nodes, more than one node. So basically we are getting into this condition. H equals to temp. Temp is pointing to the node which we want to remove. Okay. When you come at this point, which is highlighted over here, so when we come at this point, so basically H is pointing to the node which has to be removed. So H is pointing to the first node because we want to remove the first node. And at the same time, H of next not equals to H. So this condition is also true. Why it is true? Because there are three nodes in our list. Okay. So the first node next pointer is pointing to the second node next pointer is pointing to the third node, and third node next pointer is pointing back to the first node. Okay. And first node is pointed by H. So H of next is not H. It is pointing to second node. Okay. So there are more than one node. So this condition is also true. What we are doing into this condition, when we have this two conditions true, so inside this if, we are simply writing H equals to H of next. What we are doing? H equals to H of next. That's all done. Come back to this example. Your list is 10, 20, and 30. When our list elements are 10, 20, 30, and this is a circular linked list, 10 is pointing to 20, 20, H. First of all, H is pointing to 10, 10 is pointing to 20, 20 is pointing to 30, and 30 is pointing back to 10. I repeat, 30 is pointing back to 10. Now, what's happening that when you want to remove the first node, so we are simply writing here H equals to H of next. The moment we write H equals to H of next, our H was pointing to 10. H starts pointing to 20. H starts pointing to 20. That's all. 20 is pointing to 30. But 30 was pointing to 10. I repeat, 30 was pointing to 10. Okay. And now we are removing 10. We are freeing 10. If you see the code, so after this, you directly come to this point and here you free 10. So you have freed the node 10. The moment you have freed the node 10, 30 was pointing to 10. Now we do not know where the 30 is pointing to. This is circular linked list. We have to be very much careful. So the moment your first node has been changed, your first node is removed, and 20 becomes your first node, then your last node should point back to this new first node. I repeat, the last node 30 should now start pointing to this new first node. New first node. The new first node is 20. And this we are not doing over here. This we are not doing over here, which we need to do. Okay. So we need to make the last node next pointer point to this new first node. So the second node is becoming a first node now because we want to remove the first node. So the last node next pointer should point to the second node because the second node is now becoming the first node. Okay. And that we are missing over here. and because of that, our code is getting break, and our list is getting destroyed. Okay. So again, if I execute this part, I put up 10. It says me given node removed, but when I try to display, when it traverses the list after that operation, so the last node next pointer is not properly modified, and that's why our list is not intact now. So now when we try to perform any traverse operation on the list in the form of display, in the form of any other operation, so we'll get this kind of issue. Okay. So here we need to what here we need to modify the thing. So how we'll be doing that? First of all, I will put this to the curly braces, and here we need to again traverse to the last node, and then we need to make the last node next pointer to point to the second node. Okay. So mm, into this, we can make use of a preview pointer. So preview equals to h, and while this is just for traversing. And since I'm not using preview after this, so that's why I can make use of preview. So preview equals to h, and while preview of next not equals to h, preview equals to preview of next. Okay. So this loop will take us to the last node, and finally preview will be pointing to the last node. And after that, I need to just write preview of next equals to, now since h has been modified and h is pointing to a second node, and that node has become a first node, so I can write here preview of next equals to h. Now this should work. Let's see this. I need to again start. Code got executed. Sorry, code got compiled. Let's execute it, and let us insert few nodes, 10, 20, and 30. Let me display. Okay. Let's remove the given node. Suppose the given node is the first node. Let's display. Oh, still not getting done. Remove given first node, and it is not the only node. So h equals to h of next. Until equals to h. Okay. And while crew of next node equals to h, crew equals to crew of next, and then finally crew of next equals to h. It should work. This should work. What's the problem over here? Any idea? H equals to H of next. So H starts pointing to the second node, and then I write P equals to H. So I start from the second node, while P of next not equals to H. No, no, no. We, we did a mistake. Oh. So this is checking for the earlier value of H, and we are modifying H over here. So this should not happen. Let us first move to the last node according to the earlier value of H. Okay. Then let's modify the value of H the moment we reach the last node. So now we can safely modify the value of H. H equals to H of next, and then P of next equals to H. Then P of next equals to H. Okay, now it should work. Close color. Let's test. Insert and insert 20 and insert 30 and display 10, 20, 30. Remove the given node 10. It says removed, but let us display. Yes. So 10 has been removed now, and now it is 20 and 30. You can check for the remaining conditions. Go for the remove given. I remove the last node 30. Let us display 20 is there. Then remove that node also 20. Let us display. So let's see empty now. Okay. So it's going on properly. Okay. So now the all conditions are working. Only with that one change. So this is how the sequence of statements are so important. What should be written where? So the moment we are writing H equals to H of next, so basically we are modifying H, and we have modified H. So we cannot then go to the last node because the last node next pointer is pointing to earlier value of H, the earlier first node. Okay. So we cannot modify H before moving to the last node. So first let's move to the last node with this while loop. And once we are at the last node, then we can modify the value of H, and then we can set that last node next pointer to a new value of H. Okay. So this is done properly, and now the code is working. Still, there is a possibility you can compact this code. Still, you can make the code efficient, no doubt about it. Improvement is always constant. So you can change this code. And then the last function is remove before. Oh, remove before. Remove before as such. That function itself is a little tricky for the SLL. And now we are modifying it for CLL. If the list is empty, if H is null, so the list is empty. Here we are checking or we are searching for the given node. So the searching would be same as we did earlier. This should be temp of next not equals to H. And then after this, you need to check for the last node data. So that way you can do. This condition would be as it is. Should we do it now, or you want me to stop? Which lecture you have after this? Which lecture at 12? Oh, modifying this will take another at least 5 to 10 minutes. Okay, so we stop. We stop here. It is now 11:50 almost. What I will do the modifications and I will share it with you. And then, if time permits, then we will go for the explanation of same. Else, tomorrow we'll talk about the doubly linked list. Okay. So this is the last function which we are modifying for CLL. Once we do this, so the implementation of CLL gets done. Okay, let me stop the recording.